equation. We're going to move on into talking about how ionic bonds will be named. But to start with, we need to talk about the parts of the chemical equation. When you see a chemical reaction occur, when two elements or compounds mix together, there is a reaction. And when that reaction occurs, there is a formula we use to see what's actually happening. So, what we have on the left side are called our reactants. Our reactants are what is reacting to produce our product. Both sides of the reaction will always be equal. Always equal. Because what goes into reaction must come out of a reaction. Visibly, some of this may be a gas, for example, like hydrogen, and you may see that produced, but you won't exactly be able to, maybe weigh out the mass unless you had it contained. But our reactants in our products will always be equal. So it's just how these numbers move around. We're going to talk about these numbers right here. These numbers out in front of an atom are called coefficients. And when you put a coefficient in front of an element, what you do is it's almost like you've put parentheses around the element and you're multiplying that number by every other number. Sometimes we have little subscripts behind it. We can't change those. These are how our how our compound is made. We can't change the chemical makeup of the compound, but we can change the amount of that compound we have. These numbers behind it, these are called our subscripts. And these are what we cannot change. But we can change our coefficients out in front of them to make it balanced and equal on either side. This in the middle means yield or produces. Okay, so we yield or produce some sort of product whenever we are in our chemical equation. That is the purpose of our reaction, is to produce something else. So if we were to draw this and we were to use purple as H, green as Cl, and blue as aluminum, let's draw that out. Here I see that I have two aluminum atoms, so I put two blue dots. On the right side, I have two, and there's one aluminum right here, so I have two aluminum atoms. So I'm going to draw 1 and 2. All right, hydrogen. I see that here I have 6 hydrogens. So let me pick up my hydrogen. I chose purple. So I have 6 hydrogens. So I'm going to draw it like this. 1, 2, 3, 4, 5, 6. And I have 6 chlorines bonded to that hydrogen because I took the 6 and I put it with everything in this compound. 1, 2, 3, 4, 5, and 6. Now on the right hand side, I have 3 chlorines for every 1 aluminum, and I have 2 aluminums. So I'm going to put 1, 2, 3 around this one, and 1, 2, 3 around this one. Now, for our hydrogen, which I have as purple, I have 3 H2 molecules. So, what I have is 3 times 2 is 6 hydrogens. And they're H2 molecules, they're together. And I have 3 of those. So that is how it would look visually. Now, down here at the bottom, the reactants in my first equation A are 2H2 plus O2. And the products in equation A are 2 water molecules, 2H2O. For equation B, our reactants are MgCl2, magnesium chloride, plus 2 sodium atoms. And our products are 2 sodium chloride, 2 salt, that we call that table salt, 2 sodium chlorides, and 1 magnesium atom. 2 sodium chloride compounds and 1 magnesium atom. So it says, what do coefficients tell you about the atom compound, or molecule. The coefficients tell you the total number of atoms, compounds, or molecules in the equation. Okay? The subscripts tell you the number of atoms of a specific element. So if I had to write equation A as a sentence, here is how we would do it. I would say 2 molecules of hydrogen react with 1 oxygen molecule. And remember, oxygen is 2 atoms of the same element bonded together to produce two water molecules. So be sure you have this on yours. Okay. Now I'm going to flip to the back where it talks about chemical bonding. We know that bonds can be ionic or covalent. Today specifically we're going to talk about ionic. And ionic bonds are between metals and nonmetals. And they're electrons because metals are positive and nonmetals have a negative oxidation number. That means that they are going to transfer their electrons. So step 1 in naming these compounds is to name the metal first. Step 2 is to name the nonmetal plus IDE as the last syllable. I think that's how you spell it. So for this, what I mean is your nonmetal will be like chlorine. If you were to clap out chlorine, the last syllable would be ing. So I would replace that with ide. So my example could be MgCl. That's the chemical formula. I would name that by naming the metal first, magnesium. And then I name the nonmetal, drop the last syllable, and put ide, so chloride. That's all we do. Okay? So what I want you to do is I want you to grab a highlighter. And on the back of this page, we are going to look at how we write the chemical formulas for ionic compounds. We are only looking at ionic today, so please stay with me on that. With ionic, if you grab your highlighter, we're going to see that they only contain, if we're talking about binary ionic compounds, binary is going to imply they're only going to have 2 different elements. So they have 2 different elements. The 2 elements in an ionic compound would be a metal and a nonmetal. So the metal forms the positive ion because they lose electrons. When forming compounds, they're called cations. The nonmetals form the negative ions because they gain electrons. So any combination, when we're naming them, we write the name of the element that forms the cation first, the metal. Then we follow with the name of the anion or nonmetal. And then we end with the suffix IDE. So let's try this. Right here I see potassium and iodine. It is very important to understand that when you're looking at 2 elements, this is not Ki, it is K and I, because that is a capital. A capital starts a new element. So I have potassium name my metal first. Iodide. Aluminum oxide. Lithium nitride. Calcium chloride. Magnesium bromide. And if you spell these wrong, that is okay at first. You'll get the hang of it. And lithium sulfide. The big thing to remember is that IDE is going to go on the end. Okay, now what I want you to do is I want you to flip to this. We're going to talk about, well, how did we get from the name to the chemical formula? So I see this name, aluminum oxide, and the first thing we want to do in order to write down the formula, it's not going to be ALO all the time. I mean, that's really not the formula for aluminum oxide, and it may be easy to think that when you're just naming them in such a simple manner. We know that ionic bonds transfer electrons, and so we're going to have to show that in our chemical formula. So the first thing we do is we locate the charge of the metal. The charge on aluminum, if you look above aluminum, is +3. Charge on oxygen is -2. So we identify the charge by writing it above the element names. Let's just do that in the example. We have +3 and -2. And then we use the symbol. Okay, so I'm going to write Al and O. I'm going to write +3 and -2. And it says then we transfer the ionic charge from the cation to the anion. So right here, we're going to write a +3 and a -2, and we are going to drop and swap. Okay, so drop it and swap it. We drop and swap the charges. So aluminum will get the 2, Al2, O will get the 3, and we'll write Al2O3. You have to do it in this way. Skipping it and trying to do it in your head will always end in you making a simple mistake. I do this every time, and you should too. So calcium has a charge of +2. Chlorine has a charge of -1. So I drop them and swap them, draw your arrows. Ca will get the 1, and chlorine will get the 2. Lithium is +1. Phosphorus is -3. So when we drop and swap them, lithium gets the 3, phosphorus gets the 1. And we don't have to write the 1. 1 is assumed. Potassium is +1. Iodine is -1. So when we drop and swap, we notice they both have the same. So if you see ones or they're both the same, you don't have to write them. So we just write K-I. Be sure they're both capitalized so we know they are different elements. Cesium nitride. Cesium is +1. Nitrogen has a charge of -3. And remember, I'm getting these from the periodic table. Just look at your charges above them. When we drop and swap them, cesium gets the 3. Nitrogen gets the 1, so I'm not going to write it. So the times that you won't write it is if it is 1 or if both have the same charge. So let's look at the back of this page, page 10. We have sodium bromide at the top. Now, I am trying to find the formula. When you try to find the formula of an ionic compound, I want you to write here, drop and swap charge. You have to show your work or you will not get credit. Sodium is +1. Bromine has a -1 charge. Now, I know that when I draw my arrows, sodium is going to get a 1 and bromine is going to get a 1. So I'm going to leave both of those off. But let's say I'm doing something a little different. Let's say I'm doing one like barium fluoride. Barium has a +2 charge. Fluorine has a -1 charge. When we cross them, what we'll get is barium will get the 1, so I'm not going to write it, and fluorine will get the 2. So we are writing the formula. They give us the name. We don't need the name. We're writing the formula. Let's do magnesium sulfide. This is number 3. Magnesium is positive 2. Sulfur is negative 2. So I drop and swap the charges. Now here's what I want to show you. If you have equal and opposite charges, you drop them all together. So it's going to be MgS. So the only times you won't write it is if they are 1 or if you have the same charge. Calcium has a positive 2 charge. Chlorine has a negative 1. We draw our arrow, and calcium gets the 1 from chlorine, so I don't write anything. And chlorine gets the 2 from calcium because we're swapping it. So I hope you can see it does get messy, but you do need to write it so that your brain is thinking through, I'm dropping and swapping the charges. Now, the good thing is, when you look down here and they give you the formula, what they want is you to put the name. The name is simple. We name the metal, the nonmetal, and iod. So here I have K and O. Potassium oxide. Magnesium iodide. Aluminum chloride. And don't forget that your periodic table has the names of these elements on them. Calcium bromide. Okay, I want you to do the rest on your own. All right?